Well, I've been talking to myself for the last 20 minutes. Pressed the wrong button, didn't I? Nothing was recording. So, we've got a Jesan KT3003. We did one of these about 2014. I don't seem to have got a circuit diagram. And this presented as it was lighting up, PA was working, no transmit, no receive. So without the circuit diagram, I reached for another set with a proper service manual which uses the LC7137, and I plumped on using the Realistic 2002. And I was saying in the video, because this has got detailed information about the synthesizer chip, detailed information as to how it works, and what we came up with from the circuit diagram is that I had power on pin 20. I put the frequency counter onto pin 11 and 12, which should be across the 10.24 reference crystal, and I got no activity. I then reached for the RF millivolt meter, and I found activity on one pin but what on another. We'd put the frequency counter on, we got nothing. I then looked carefully and I spotted that one of the crystal legs was dry joint. Because it was tarnished, it was making no connection at all. So cleaning that and resoldering it has brought back operation. So that's how to do a précis of 20 minutes of video. So what we've done is to go through the transmitter. I can't quite get it on frequency. Whether or not that's because my test set isn't warmed up yet, we'll come to that later. It's a bit high, it was a bit low, and now it won't go quite where I want it to go. So it's not good enough to use. And what I'm going to do is going to take a black and white photo like I did with the Spectrum M8, the PT40 version. We did a black and white photo and filled them in with the usual markers that I do. Instead of drawing a scribbly hand one, I think I'm going to be doing them on a black and white photo in future. It just seems a better way to do it. And it does mean I can scan those, and then they're in the file on the computer under the relevant set. And we found that on transmit, we've got transmit, 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 and then it's setting this coil for maximum. We managed to get 3 watts out of the set, and on low power it's doing 350 milliwatts. We then found that on transmit we get all the lights light up even though it's 3 watts, and on low power we get 2. Oh, it's now 1. It was 2 a moment ago. And we found that the RF meter adjustment is the preset there. So that's where we've got to, and I was going to go and take a break to go and get the camera and take a black and white photo. And the other thing about this set is a Cybernet pin out, so I'm using our Cybernet test mic, and we've got a nice power lead on it. It's actually not better than the usual 2 inches poking out of the back, but for some reason the fuse holder's gone missing, so of course we will replace that. I was also saying that I felt these sets were probably in the 1989-1991 category, and that I did think they were really at the bottom of the range, one of the cheaper sets. I think they were the kind of $49.99 type of bargain basement. So it's doing 3 watts, but that's on our rather tight test set. It's probably doing nearer 4 on something like a Zetagi meter. So we're going to pause the video, I'll get the camera, we'll take that photo, print it out, then we can start filling in the I do my colouring, because I obviously missed out as a child on colouring books. Right, so there we are, that's what we've got with our photograph. The 3 coils that affect transmit, the one which has to be twiddled with, and the TX meter is where we are so far. So we need to see if we can find the deviation. Just need to tune this back in because we were doing ham radio lasts and on UHF. So there we are. We got it. 1 2 1 2 1 2. It's there somewhere. Wallow. Very quiet. So we're left with that preset, that preset, that preset. Let's go for that. Wow, that's on full. Let's hope that's enough. 1 2 1 1 2. Yeah, just about enough. It's not ideal, but that's the maximum deviation we're going to get. Wallow. Just check I am tuned in again. Wallow. I was wrongly tuned in. Wallow. 1 2 1 2. One, two, wallow. That seems to be about where we want it to be. So we can add to our little list the preset there. Fill in the arrowhead. There we go. Right, well, can't be much left to do. Now, it was receiving very well on my initial test. So we'll plug the equipment into the extension speaker socket. I'll just see whether we can trim the frequency actually first. We'll forget about that a moment. Or whether I've got to get through a fault on it. So we'll put the frequency counter up and see if we can get it anywhere near. So we should be on 27.79125. It wouldn't go anywhere near. So I'm going to waggle the trimmer around. No, it won't go anywhere near. I just wonder if there's some dry joint capacitor or something, which I'll just look at that behind the scenes. We'll pause the video. Now I don't know whether this is going to affect it, but I have spotted another wicked dry joint, which is there. Now that looks to be like an electrolytic capacitor on the other side, but it's right in this frequency control area. It's right there, so it could be that resistor, it could be that capacitor. It's in all that waxy mess, so I think that's going to be very important to frequency control, and I've probably hit the nail on the head with that dry joint. So it looks like these can be prone to dry joints. Just see if we can zoom in any more and actually use the overhead camera as a microscope. Got to find where I am now. I'm there. So it was there we were looking at. Just make sure the set's turned off. Just going to have a visual inspection around the area. We'll put the camera back to its normal position. Right, well, we'll see what happens. So we'll switch it back on. Go into transmit. And see whether it makes the slightest bit of difference. It doesn't, no. We'll have another look. I'll pause the video. Right, it's time for the educated bodge time. What I've done is to put a capacitor across the crystal. Although it's not physically across the crystal, this is on one side and the other goes to the IC pin 1. So it's between IC pin 1 and 2, and that is 10 picofarads. Now I tried a 1 picofarad and the swing wasn't enough. Now you can put too much on and it'll stop oscillating. So let's see whether we can trim it. Hopefully it's cooled down enough, having soldered it. Switch the set on. So I'll probably have to check this later, but we'll see whether we can trim it on frequency. We're at 2779, so I've overshot it. (27.79128). That'll do me nicely. I reckon this has been off frequency since the day it was made, because considering it's 30 years old, you know, the crystal will have dropped with age, and it's still off frequency. So there we are. It must have been awful. No wonder it got discarded. But that's a little cheat if you want to pull a crystal down a bit. You can't pull them up though. Good. So we're still doing 3 watts. I think we're on low power. Yep, still doing 3 watts. Let's see what it sounds like on our monitor receiver. Testing 1 2, testing 1 2, 1 2, 1 2. What on earth is wrong with that? Wow, that is awful. Wallow. Testing 1 2, 1 2. I think we need to be back on the deviation on this. Now, why is that drifted? It jolly well has. One, two, 1 2, wallow, 1 2. Testing 1 2, testing 1 2, 1 2, 1 2. Right. Right, we'll go back to receive, because I didn't want to set the receive with it being off frequency. We end up with it lopsided. I'm not a lover of slider controls, I'm sure you're not. Let's look at our oscilloscope. So we'll put S9 signal on the signal generator. Turn the bench light off. Drop the volume a fraction so we get a sensible size display. So we need to be hunting for the detector coil. So I'm looking, I'm assuming that's going to be the IF chip. So if that's the IF chip, I'm expecting that to be the detector coil. But it isn't. Now it could be the one next to the 455 filter. And it is. So it's kind of best peak for best shape. It was that one. Was that one? Why didn't I? Don't know. Perhaps they were so out that that wasn't having the desired effect. Anyway, we've got the right shape. We've got the peak on there, so that is the detector. So we'll now go through with the cyanide meter and we'll do everything else. So we'll put the signal down so the radio is not saturated, and I usually go to about 4 dBs. I'm expecting the front end to be these two and the IFs to be what we've been playing with. So that was peak. I will make sure later that hasn't altered the shape. So we'll attenuate it again, see whether this one's going to help us. Let's put a bigger signal on for that one. And that leaves us with this. There we go. So looks, we'll go for, and I'll put back to the oscilloscope. I will. And we still look like we've got the best shape. But I'm going to recheck. There we are. So that should be absolutely fine. Let's see what the sensitivity is into the cyanide meter, etc. Well, it's not exactly shining, but it's 1 microvolt for 12 decibel cyanide. It's 0.9 for 10 decibel cyanide. And see what we can get, if we can get 20 out of it. It's actually 2.3 for 20 decibel sound, which is better than a lot of sets. So I think that's as far as we're going to be able to take it. I'd like to have had a little bit more sensitivity. I'm tempted to just give this another go. No, that's where we are. But nobody ever said it was the highest quality set in the world. It is a cheap set, and no doubt pretty low in the range of the Jesan products, which were cheap anyway. So we need to set up the S meter, and we need to set up, well, for what it's worth, let's put S9 signal on and see what we've got. We've actually got nothing. So it's either going to be that one or that one. Let's try that one. Isn't that one? Try that one. Oh, it's not that one either. Well, that's a bit bizarre. Right, we'll put a signal on till we actually get a reading, which is a massive signal. I've put on 1 millivolt. So let's see whether we can adjust either of those. So it's not that one. It's that one. So that's at full. So it's 300 microvolts for 3 bars. And that's the best I can set it to. So it's pretty meaningless. So that means the Squelch will be the final one. We'll turn the signal generator to standby. Oh no, we won't. We'll put it to full Squelch first. Full Squelch. Let's see where that is. So I want it to come into 100 microvolts. It's coming in far too strong. So presumably that's the Squelch. No, still not coming in. So that's our absolute best sensitivity. So it's coming in at 1 millivolt, a bit like the S meter. Well, at least it comes in. I mean, some sets it never comes in on full, which is pointless. So now we'll do the important one, which is the sensitivity. I'm going to put the signal generator to standby. We'll put the attenuator controls on the inset picture, drop the Squelch, and set threshold. Bring the signal generator back on. It's currently parked at 0.3 of a microvolt. Let's advance that and see when it comes in. Oh dear. That is not going to work. It's wanting 100 microvolts S9 to open the Squelch. So this is not going to do scratchy corner. Well, let's just see whether it's me who can't set the Squelch control. Let's give it another go. Now we'll just back it off of absolute fraction. No, it's very... No one's going to be able to set that more carefully than that. Let's switch the signal generator back on. Right, 1 microvolt, 3 microvolts, 10 microvolts, 30 microvolts, just about coming in. So the best I can see it coming in at is 30 microvolts. That is really unsatisfactory. I'll just see if there's anything we can do about that. Right, well, I've spent some time meticulously retuning the receiver yet again. We'll put it down to 0.9 of a microvolt for 12 decibel synad, which equates to 0.8. But whether or not the Squelch has improved, we will find out. So we'll set it to threshold. Now, it's like an S7 Squelch, it's ridiculous. I'll just look at this preset again. But I can't imagine that helping. Might do. No, it's ridiculously bad. So, a radio that's supposed to do 4 watts and does 3 watts. By jiggling around with that extra capacitor, we've managed to get it on frequency. We'll check that it's still... Whoops, that does that, doesn't it? Hang on, we're not on frequency anymore. Is this thing frequency hopping? It won't go on frequency. So it's now gone too low. Right, switch it on, switch it off, change that capacitor. But I'll take off that capacitor and see whether it will go on frequency in a normal way. It will. So what on earth has happened? Okay, so now it's on frequency. The Squelch will do... looks like 25 microvolts, which is still ridiculously too high. So I'm going to have to go through this receiver again to verify that the IF is right. So I'll just do that off camera. Right, well, no improvement is to be had. So there we are, that's how it is. It is a lousy Squelch. I'm sure, was there a Jesan KT3003 or something which had a lousy Squelch on CPT band? So this is going to be an interesting test when we get to Scratchy Corner. We may only get the top of the hill. We may only get 2 miles on this set because of the Squelch. But it might work better in the real world than into the test instruments. See, when I adjust the Squelch, I'm going from no noise, and when you adjust the Squelch in the real world, you actually have some noise. So it might not like the instrument world. Now, if this has changed frequency on its own, we're going to have to monitor it. Oh, I hate the fact that this does that. See, it's off frequency again now. It's frequency hopping. There's got to be a dry joint which is causing this. So that's something else to go through. So I've gone through it around the phase lock loop area, 4 dry joints. Didn't actually see any, but I've just gone around about 25 in that kind of area. The things which are going to affect frequency control, and we are back to it being on frequency. So I'm going to leave it for a couple of hours, get on with some organ work, leave it on, and then we'll come back and see. Right, I've returned to the radio. Now it's 7 o'clock in the evening, so you know, I've done my day's work kind of thing, and we'll key it up. I've not touched a thing. and we're still on 2779,123, so that's absolutely fine. In fact, I think it's doing a little bit more power. It's doing 3.1 watts. So I think we'll put it together. Right, so to conclude, one of the worst squelches we've ever come across. Just check with our little handheld. Testing 1 2. Testing 1 2. I'd be interested to see what the scratchy corner test is going to do with this, because you know, if it needs something like S7 to open the squelch, it's ridiculous. 190, Roger. Right, so there we have it, the Jesan KT3003 from round about 1980, 1990, 1991 type of era. Thanks for watching.